Today, we're going to be talking about a brief history of neurodevelopmental disabilities. Be aware that this is a big area, and I have been developing a TED Talk which consumed my life. We will just take the highlights. My name is Nat, and I deliver these webinars every single Thursday, rain or shine. Today, we are going to take a deep dive into a subject which I think can help us understand ourselves a bit better, and also around the progression we've made and also some of the stigma that still presents itself. Today, we are focusing on neurodevelopmental disabilities. You might be thinking, but Nat, you're not about that disability life. You're all about abilities and empowerment. Yeah, I know. However, history is a bit of a stinker, and they haven't really seen that as amazing in the past. That's why we're focusing on the bottom spike, not the top spikes today, because of history. Even still, history doesn't really acknowledge neurodevelopmental conditions, disorders, disabilities, or differences that much. You have to look between the weeds and see what progressions have contributed to a better understanding later down the line. Here's me for credibility reasons. Oh, look what we put there. A cheeky edit this morning. Oh, Louise, don't know what a bottom spike is. Essentially, when we talk about neurodiversity, we normally talk about a spiky profile, which essentially is saying we have top spikes, which are things we're really great at, and bottom spikes, things we may struggle at. It is a difference between the top and the bottom spike, which is what we mean when we talk about neurodiversity. History has traditionally focused on the bottom spikes, hence the names disorder, disabilities, even disease, which people used back in the day. False. But as an organization, we're a bit more pointy, more advantage and benefits. A history, and may I say a brief history of neurodevelopmental disabilities. As I said before, this is a difficult history to piece together because history hasn't really acknowledged developmental disabilities. To be honest, most of this history is just about the history of neuroscience, but we're going to be looking at how the history of neuroscience have impacted and influenced our understanding of neurodevelopmental disabilities later down the line. Obviously, by the time we get to modern date, we then hopefully shift to neurodevelopmental differences, but we're not going to get that far today. We're going to be concentrating on the bulk of history. If successful today, we are going to be looking at the scope of neuroscience in neurodevelopmental disabilities. We're going to be looking at some early studies of the brain and how they have influenced our current understanding of NDs. We're going to look at some key discoveries, look at the future. Where are we going? What can we expect? My first question to all of you is, what even is a neurodevelopmental disability? When people say neurodevelopmental, what are we referring to? When we say disability, what does that entail? What is a workshop without defining a definition at the beginning? We got a different development of the brain. That, I would say, is a very progressive way of looking at it. Different thinking, different wiring. It's interesting. All of you have been conditioned by me to be very progressive in how you're thinking. In this instance, we are referring to a disability. Neurodevelopmental essentially means our brain grows. It starts off as a tiny little pea and it gets bigger and bigger and bigger. But as it's developing, maybe it's developing abnormally. There's two ways of looking at this. Abnormally as there's genuinely something not quite right, or different to the norm. We are kind of be grouping those two in together today, because again, that's how history has looked at us. But now we know that's not the case. Different ways of learning, a disability that affects the brain and has someone perceives the world around them. Yes. So depending on maybe, could be brain damage. No, well, not really. I guess you could have brain damage early on. It could be a neurochemical influx. It could be genetic, could be environmental. For whatever reason, there is something which means the way your brain develops is not developing how the normal case study of the average brain is. When the brain develops differently, causing perceived deficits in function. Yes, I like that. Don't get me wrong. Sometimes there are deficits because not all developmental disabilities are neurodivergent, but a lot of them are. You've got impaired, different speed. Yeah, Rachel, that is one way it can impact you. Different processing, a learning disability. I think that's a fairly good understanding of it. What the dictionary says is a neurodevelopmental disability is a disorder that affects the development of the nervous system. impacting cognitive, social, and emotional functioning. Isn't this interesting that none of you mentioned the nervous system, but actually the nervous system is essential. In our brain, big squishy old thing, and the oldest part of the brain, the nervous system, like essentially makes us tick, gives us pain, gives us movement, feeling, awareness. That is the thing which is normally most affected. So a neurodevelopmental disability is a disorder. Remember, disorder simply means different from the ordinary. The word disorder doesn't necessarily mean deficit at this stage. That affects the development. Presumably, once your brain has finished developing, there are going to be no more new neurodevelopmental disorders. This is why it's from early on in the womb or early in birth. We know that the brain actually keeps on developing. Some people grow up until they're 25, for example. This is why you'll notice that some developmental differences or disabilities or mental health conditions will happen during puberty. Some types of depression or schizophrenia. They still do happen during development, but just not early development, and impacting cognitive, social, and emotional. Most of these, to be honest, are just what society has classed as normal. But it's an interesting broad. Here you can see I put neurodivergent. Are a lot of them neurodivergent? Yes. Are all of them? No. For instance, dyslexia, dyspraxia, autism, Tourette's, all of these are neurodevelopmental disabilities. However, when we talk about neurodivergence, we talk about the spiky profile. We talk about the high skills and the low skills. But when we talk about disability, we're typically just talking about the bottom spikes. Hope that clears it up a little bit. Oh yes, neurospiciness. I think that's a good way of going about it as well. I would have called myself neurospicy, but the only thing is I don't like spicy food, so I feel like it'd be false advertising. There's research coming out at the links between autoimmune conditions and neurospiciness. You are absolutely right. Actually, there's a big link between autism and things like IBS, seizures. For instance, it's connected, which is really interesting. But you are jumping the gun there because history hasn't even dreamt of connecting those dots. Or have they? Has the brain always been considered as important in understanding neurodevelopmental disabilities? You'd think so, wouldn't you? For instance, neuro, as in brain, developmental disabilities, maybe it's important. The better question is, has neurodevelopmental always been considered a thing when it comes to brain? No, we did not. The brain, don't get me wrong, has had its uses in the past, but we haven't placed as much emphasis on it being as crucial. If you're acting a little bit different, witchcraft, let's burn them. It's only relatively recent where we like, oh, actually, maybe it's to do with the inner you, your brain. Oh, apparently 50% of ADHDers have hypermobility. There is a big correlation between physical and mental. We try to separate it too much, I feel. The first thing is trepidation. Some of you might be thinking, trepidation, that's not to do with neurodevelopmental conditions. It's right. However, it does show us one of the earliest examples of humans trying to manipulate the brain in order to make it feel something or act different. What we do, say you got a nice head, all you do simply drill a hole through it. That might, 1, release your demons, 2, release some pressure, or 3, we don't know. This was something which in the early cavemen times they did, maybe to treat headaches or head injuries. As we develop into the future, we still do a type of trepidation, but it's a lot more sophisticated. However, for conditions like autism or ADHD, drilling a hole in your head isn't going to help. Oh, and you might risk it letting more demons in. Yeah, honestly, I think that's why they stopped doing it, to be honest. It was actually letting more demons in than not. Obviously joking, but it gives you an idea. Then let's move on to the Egyptians because they were ahead of their time. Egyptians' mummification rituals. Guess what they discarded? When they were getting all the body parts, what goes to the afterlife? What goes in the bin? What do you think they decided was useful and not useful? Yeah, those of you who have studied. Yeah, the brain. What a waste of time. Useless. Just a bit of squishy fat. But the Egyptians did not regard the brain as that important. The heart, the lung, those things were way more important. There is a slight misconception here that they thought the brain was completely useless. No, they did think the brain had its uses, but nowhere did they consider it essential. That is completely different to what we believe today. Did Egyptians have conditions like autism? Yeah, but they wouldn't have even dreamt of considering it being remotely something that we do today. This little document, by the way, is called the Edwin Smith Papyrus, and it's the oldest text ever on brain observations. We have evidence of people thinking about the brain and the brain's relevance, but not common practice. Why would they do that? What, in terms of throw the brain away? I don't know why, but they get rid of the brain because not useful. The others they felt that they needed in the afterlife. There is a brand new museum about Egypt's culture in Cairo, which costs $1 billion. I really will go there one day. I firmly believe that it is people like us who have created change throughout time, are thinking outside of the box, create innovation. I do believe you on that. And I do think history actually, in some instances, has been more kind to neurodivergent people because we appreciated innovation. But as we developed as a society, it started automating more. The benefits of this disorder became an inconvenience, but it hasn't always been that way. We may have not had labels like neurodivergent, but we may have not understood that the brain was different. I guarantee you, without innovative thinking, the Egyptians would never have got as far as they did. Let's move a little bit further on now to 400 BC. Galen, what a guy. A Roman Greek doctor, very notorious in his day. Anyone was anyone, they knew this fella. He studied dissection and proposed brain ventricle transmit messages. So basically, he thought the brain actually did communicate. He thought, actually, there's something going on here. If I cut the brain, he did. My question to all of you is it okay to slice and dice a brain up in order for science? That's a controversial thing. This guy, yeah, did he do people who were already dead and dying? Yeah, but honestly, people who are really sick and are going to die anyway, let's have a look under the hood. He would often do it in gladiators. So when people had literally just died, they'd be taken to him and he could operate. However, there's a lot of evidence that he sometimes does a bit of underground stuff. He did overlook neurodevelopmental conditions. That was never a thing. He looked more at lumps or tumors, that type of thing. However, even though he doesn't directly look at neurodevelopmental, not even closely at this point, the lack of looking does actually still give us a bit of information. Oh, what's your opinions on fMRIs? Hold tight, we are getting to that, you eager beaver, Louise. As long as we're not just killing people, then yeah, why not? Sometimes they were just killed, to be honest. Sometimes they were. Oh, I'm obsessed with this presentation. Nice. Then let's move a little bit on to dualism. This is an interesting thing because suddenly we're getting a little bit psychological. We're starting to think beyond our physical realm. We've got, tell me if this is not true or true, left or right. Dualism separates the mind from the brain, complicating research on neurodevelopmental disorders by limiting a holistic approach of mind-body interaction. Before, you're just a body. Don't worry, the brain, not important. Now we're like, actually, the brain is important, the body is important, but they are separate, dual, as in two. Yet we are making headway, but they do not understand they connect. Essentially, what is our body without our brain? Nothing. They didn't really get that. The observable brain and body aids in understanding neurodevelopmental conditions. Individually, yeah, but I'm not sure they believed it as a whole. The non-physical mind complicates studying these conditions. Ethical concerns arise in animal research on brains versus consciousness. Essentially, we were okay with doing these tests and jibbing and jabbing the brain, as long as it wasn't on people. Ultimately, dualism was wrong, but we were getting onto the right train of thought. We were starting to at least think about what might be functioning together and what might not be. History, we're getting there. We're not quite there yet. Then in the 1700s, we've got The Autonomy of the Brain. What a banging book. It was the first illustrated book on the brain, or the first kind of mainstream one by Thomas Willis. And this looked at how our brain has reflexes. It talked about epilepsy, even the way back then. It talked about paralysis. And you can see really detailed illustrations. Some of them factually incorrect, but still a lot of them hold up today. Must be mentioned, there is no mention of neurodevelopmental conditions. Of course, autism, dyslexia, dyspraxia as names come much, much later in time, but even the idea of it isn't truly mentioned. Before we even get to autism, we must go first to schizophrenia, then possession and witchcraft. These polarizing thoughts did happen at the same time to each other. Just because Thomas Willis had these great ideas didn't mean that they were in the general consensus. He first described reflexes and brain conditions and introduced the term neurology. Until this date, there was no such thing as neurology, or nothing that we could name it. Let's face it, the brain, there's a lot going on there. How do we even understand it? How do you study something, particularly from a neuroscience perspective, not psychology? We're going to need a microscope. In the 1700s AD, this is when we started to create microscopes. We had microscopes before this, but they were junk. This is when we got really good microscopes, 200 times magnification. I want you to have a look. Which one do you think is the 200 one? Yep, is this one. Look, that is really good detail. It is nothing in comparison to what we have today, but it meant that we could start to see neurons. In our brain, we've got lots of little cables and connections, and there is way more detail than that. But now we can actually see that the brain is filled with connections. It revolutionized nervous system studies, the bigger parts of our brain. It paved the way to understanding. Don't get me wrong, that's still really impressive. You wouldn't be able to see a neuron, but what about things like the synapses or the neurotransmitters? Really, you know how we talked about dualism, how the brain and the body are separate? We've been able to rejoin them back up together and know that actually one does directly connect to the other. Some of you might have heard of this one. Yeah, Galvani. He is very famous for discovering that the nervous system communicates with electricity. Mind blow. Our nervous system, remember, which is like the oldest part of our brain. And when we interact electricity with it, our body can move. This tells us that the brain does have cables, it does have wiring, and those wirings are directly impacted by electricity. We haven't quite got onto the chemical side yet, because remember, our brain uses electricity and chemicals collectively to operate. We're just focusing on electricity at the moment. But what he essentially did is he got a frog, a dead frog, and he got his nervous system and applied a little bit of electricity to it, and then the frog started moving. That would have only happened if there was a connection. His animal electricity research paved the way for studying ADHD and autism. It did, but paved the way is maybe jumping the gun a bit. Galvani's work advanced neuroscience and inspired the battery invention. It did that as well. It did both. It really did do both. We can't understand ADHD and autism, for example, without understanding the nervous system. Because again, the nervous system is one of the very first things to develop. It is crucial, but in terms of how crucial, that his research will become more prominent later on. Right now, they're just enjoying the fact that the frog's legs. Let's keep going with the century, because the 1700s, there was so much going on. Let's look at Mary Shelley's Frankenstein. You might be thinking, Nat, what does this even have to do with neuroscience? It's complete fiction. It is fiction, but it shows you that people were excited about the brain, that they were intrigued by the brain. It tells you a lot about the cultural perceptions. If people in the future look at us now, they will think, you know what? Yes, they didn't have killer robots, but they were interested in AI. You can see the parallels. Frankenstein shows you the type of themes. It explores themes of acceptance and otherness, maybe not neurodevelopmental. It does depict how individuals can feel othered and shunned upon, maybe an early predecessor to what we now call as stigma or bias. Then we got no, it focuses mainly on scientific ethics. It does, but it's not all it does. And we've got partially touches on societal rejection. Does Frankenstein show any science to neurodevelopmental? No, but it does show how difference is othered and difference is seen as a negative. But when we talk about advocation these days and champion the cause, honestly, we've been doing that a long time. We just haven't had the same progressive language. All right, nice. Well done, everyone. All right, moving on another century, the 1800s. We're looking at the Bell-Magendie Law. And this relates to the history of neurodevelopmental disorders. Essentially, in our spinal cord, we've got different, what we call roots, and they are responsible for carrying motor signals. One goes one way, the other goes the other way. Motor signals is movement, and sensory information is things like responding to the world around us. Hey, didn't we already mention earlier on that ADHD is heavily connected to motor signals? Yes, we did. Don't we know that those with autism can often struggle with sensory information? Yeah, we do. Understanding about how these routes are responsible for sending this type of information has a direct link to neurodevelopmental disorders. If one of these isn't working correctly, there may be a delay. Something could be slowed down. Something might be more sensitive. Essentially, it changes the gauge to our kind of base normal to abnormal. We've got clarified brain functions for neurodevelopmental disorders. Yep. We now know that if something is dissimilar to the norm, then maybe that could have an impact. Focuses on movement, ignoring cognition. Nope. As we said, there are two ways. It is both movement and cognition. Downplays the brain's importance. Absolutely not. If anything, this shows how essential the brain is to movement and sensory information. We didn't know that. Emphasize emotions, not linked to disabilities. No, absolutely knew it was disability. For instance, if they notice that this wasn't developed in the conventional way, they could often relate it to some symptoms or some abnormal behavior. So this is a big step in the right direction. But you will see for most of these things, they are way more important in the grand scheme of science than purely just one area, such as neurodevelopmental disorders. But without these discoveries, we wouldn't know half as much as we do today. Well, let's look at Darwin now. Darwin was great. The history of evolution. I want you to look at this lovely chimpanzee and tell me, what is the chimpanzee thinking? Because Darwin was really interested in the theory of evolution and how we communicate. We know that one of the biggest challenges of having a neurodevelopmental difference is communication boundaries and challenges of interacting with the world around us. How can we learn more about that? By understanding how others, including our animal counterparts, have learned to interact. Do chimps interact in the way that you would imagine? Does a smile always mean a smile? Or can different animals or different cultures or different entities show similar facial expressions, but with completely different meanings? We think that the way we express ourselves are universal. It is not. And this was already starting to be observed with Darwin. Darwin's idea linked emotions to brain functions. Remember, before Darwin, we were linking movement and sensory information. Now we're linking emotions to brain functioning. Suddenly, the brain went from not being important to being, oh yeah, the brain's responsible for that. The brain is becoming incredibly important. It suggests behavior in autism and ADHD being biological roots. Yay! No longer are we possessed by demons. Now we know that is biological. It is a natural part of being human. We haven't quite got to the part where it talks about development, but we have got to the part where we know that the brain is the kind of the core hub of all of the areas that those who say autism may find challenging. Okay, we've got recognition, wanting to talk and laugh. Hopefully you get the point here. All of us interpret his emotions completely different depending on our own prior experiences. It takes a massive collective to categorize certain expressions into a perceived meaning. Those with autism will typically not align to what the majority feels is the kind of correct response. If you get socks at Christmas, some people will be like, yay. Some people with autism might be like, I didn't want socks. That's a little bit rude. However, you're honest. It's just a different way of interpreting the world. I use that as an example because that is very true for me. However, the older you get, you do realize actually you do like socks. It's interesting, isn't it? Age changes you. Nothing like a fresh pair of socks. Moving on, let's look at phenology. And this is essentially looking at the bumps and lumps in our skulls and contributing it to traits and abilities. It should be noted, completely BS. There is no truth in this. It's still really interesting on terms of the brain and how it has developed differently. Again, we're talking about development at this point. It has a direct relation to, for instance, your traits or emotions or your output. In here, let's say you had a dent here, a lot of hope, maybe tune, time, depending on where you've got a bit of non-normality, could depict your personality or your behavior. Again, not true. But hopefully you can start to see how we aren't too far away from understanding how differences in our brain structure does have an impact on all these areas. Yes, it's not the skull and it's not the bumps and lumps, but it is the brain. We are almost there now. We all know Mark Twain, right? You know, the famed author of Huckleberry Finn and Tom Sawyer. He was a bit of a cheeky guy and he used to love playing pranks on people. Under a fake pseudonym, a different name, he found that there was a cavity. He went to a phrenologist and they said he found a cavity and startled me by saying that a cavity represented a total absence of the sense of humor. 3 months later, using his own name, now the cavity was gone and it was placed with the loftiest bump of humor he had ever encountered. What we're saying here is there was no consistency. One day they might think that you're insane, another day they might think you're a genius. Not true. Whereas our current understanding is that while we don't exactly know what autism is, we do know that if there is a delay in a certain area of the brain, that will have a direct correlation to a disorder. It doesn't matter what doctor you go to, they're going to come to the same result because we're actually operating on science now rather than make-believe. Okay, on this one, I want you to place a little pin on the brain part which is responsible for vision. This is just to show you that while phrenology was wrong, it wasn't too far off the truth, that there are parts of the brain which are directly responsible for certain functions. You're right, it's the back part of the brain. There are other parts of the brain always works. People think, okay, if I get stabbed in the front of the head, that's not going to affect my vision because the back part is fine. It's all interconnected. It's all essential. But this is the predominant area. This is the oldest part of the brain. As the brain branches out, that's where we get to the more modern part, which is more distinct and unique to humans. Now, as Louise asked for, what about fMRI? This is what we're talking about when we're looking at machine imaging. For instance, we can see that different parts of the brain have direct relations. Let's say this part of the brain has a direct relation to language and touch. This part is predominantly done for vision. This area is mostly related to balance and coordination. Those with dyspraxia, coordination challenges, the cerebellum might be an area that they may look at. Those with dyslexia, it could be the frontal lobe. Frontal lobe, for a lot of us who struggle with memory, we are starting to make sense of the brain. It should be noted, it is oversimplified. It's all interconnected. And we learned that through the case of Phineas Cage, the guy who got a big pull through the eye. Yeah, it looked like he was completely fine because a bit of the brain was missing. But as time went on, they realized that he wasn't quite the same. How do people know which part of the brain is supposed to do what? They can do that by using different MRI scans. For instance, let's say you're all connected up maybe to an EEG or different software. They ask you to touch things and feel things. They will see an increased activation of your brain's electric pathways. Remember how Golgi taught us that the brain has electricity in it? Essentially, if we are using a part of the brain more, there is more electricity, more activation. Almost similar to your computer, where if one area is being used more heavily, it gets hotter. That will show you that that part is in use more. This is why if you ever see pictures of the brain, you'll sometimes see they'll make it redder or darker. The brain doesn't actually do that. It's more of an illustrated perspective to show you what areas have more activation. But yeah, we can directly see what areas are being more heavily utilized. Those images, though, can be a bit deceiving because it makes you think that, oh, it's only the cerebellum that is in use. No, it's all in use. Just the predominant activation is in the cerebellum. Golgi and Ramon y Cajal were instrumental to understanding the brain. Essentially, they started documenting all our cables. Our brain is incredibly complex. These two hated each other, but together they jointly won the Nobel Prize in science. Golgi saw the nervous system as a network, and Cajal saw it as an individual neuron. One of them thought the brain essentially was just one big old heap of computing power, and the other one saw it as lots of different ways of thinking. Do you know which one was right? A key distinction for neurodevelopmental disorders. Is autism just one big block, brain autism, or is autism just one tiny part or lots of parts all interconnected? Oh, wow, okay. Yeah, it is as individual neurons. They both were onto a similar line. The nervous system as a network, Carlyle saw it as individual neurons. The brain is lots and lots of tiny connections that connect to each other. In essence, essentially, you've got a neuron, which is like a cable. Then you have a gap, you've got the synapse, and that's where you have the electrical chemicals, and you have another neuron. So they aren't actually connected, but they do all communicate with each other. As I said, they did win the Nobel Prize. A famous quote is, "What a cruel irony of fate to pair like Siamese twins united by the same shoulders, scientific adversaries of such contrasting characters." What he's saying here is that one of them was onto the right idea, the other one filled in the blanks and got to the end goalpost. Without both of their ways of thinking, we would not have the knowledge we have today. Unfortunately, they were like arch rivals. They won the Nobel Prize, but bit of a kicker, to be honest with you. Again, we're just dipping into bits and bobs here because the history is complex. We're almost at current time now, 1900s, and we're looking at the nervous system having a hierarchy. I want you to rank here the hierarchy of our brain, how the brain structures and functions connect to behavior and cognitive ability. A lot of people think that the top part is the brain. Our brain is actually the whole part because it's all connected. Yeah, the forebrain is that bit, the brain stem is that bit, and then got the brain cord. Essentially, this is the oldest part of the brain, and this newest part is a new bit. Because autism, dyslexia, and ADHD are very much a human condition, animals don't have it, it refers to the newer part of the brain. 1920s, Otto, what a cool name, experiment shows that nerves communicate using chemicals. Woohoo! We finally got to the neurotransmitters. That is still a really new discovery when you think about it. We've known for quite some time about electricity, and that obviously led to Frankenstein because learning that the body is controlled electricity. But we didn't know about things like dopamine until relatively recent. They were able to show that different chemicals can operate different hearts. And just like we learned with electricity, we also learned it via frogs. Those poor frogs, they really get a raw deal of it, don't they? We would stimulate one heart, which would slow another heart down. When we would stimulate one heart, it would send chemicals and that would interact with another heart, slowing it down. This was not done with electricity, but purely via the chemicals. This is where we learned about that connections. Remember how I just told you a minute ago, how you have essentially your two neurons and then in between you have the chemicals? This was exactly what it was. Chemicals go from one and then there's this kind of ether and then they kind of get up again. That is how our brain communicates. So electricity and chemicals. With neurodevelopmental conditions, it is a combination, typically more chemical. So those with ADHD, their brains will often struggle to send dopamine from one synapse to another dendrite, or it might get sucked up too quick and recycled poorly, or they might not produce enough, they might send too much out. So the exact reason of where the difficulty lies is kind of a needle in the haystack. But we do know that this is essential to understanding neurodevelopmental conditions. In total, we have had so many discoveries, and our discoveries are ramping up. We are getting more and more. This is an area which is still evolving. Maybe our current understanding will be seen as so kind of archaic in a few years down the line. In the 60s, we had Nobel Prizes that advanced neurodivergent research. In the 70s, we had Society for Neuroscience, which means people started taking it science and played an active role into it rather than a few others. In the 80s, the Human Genome Project reveals genetic links. So we now know that certain genes do have a direct link to things like autism and ADHD. We don't know what yet. We don't know why. We don't know what gene, but we do know that there is a connection. In the 90s, this is when I think it was President Bush decided to invest really heavily in the brain research. And this was coined as the decade of the brain. Then in 92, we had the first MRI machine, which we could directly see what parts of the brains are activated in certain individuals. Those with ADHD will have certain activation compared to neurotypical people, which might have less activation or more activation in different areas. 2013, we had a brain initiative that continued to enhance our understanding. Again, this is the tip of the iceberg, but it shows you that research is making massive headway. We haven't stalled, we are learning. This brings me on to the future, 2000s onward. Is there any area which you think you are most excited about, which potentially might have the biggest impact to helping us understand our own neurology better? Maybe it's CRISPR, which is essentially gene editing. We know that autism is genetic. It's lots of different genetic genes, but what if we could cut them out and essentially get rid of the autism? Controversial. I'm not a big advocate of that, to be honest, but maybe you are. Or could we use it in another way? Then we've got, you could control the brain with different lasers. That's really interesting. Maybe if you want to support someone, rather than having to drill a big old drill through the brain, you could just do it via different lasers. And this is really interesting where essentially you can control a mouse. You could essentially treat it like a remote control car. I don't really see that being useful for neurodiversity. Then we've got different prosthetics, how you can essentially make a cyborg, okay, not that useful. Then we've got computational neuroscience, model ND for better treatments. This will definitely have the biggest impact. We have not mapped the brain yet. The brain is insanely detailed. However, we aren't far off. And once we do that, it will get faster and faster and faster to map individual brains. Then we may even be able to start to map neurodivergent brains. And we can use computer models to see what areas are functioning, what areas are not functioning, what is having a deficit in certain neurotransmitters, what is having an abundance of it. And that may help us fill in some of our current gaps in knowledge. Honestly, it's so interesting. Oh, we got, I wonder why do people mostly tend to be arrogant and tend to think that they know everything at the time? It's a good question. I guess it's maybe a lack of imagination. We only know what we know. So to try to imagine a future, you go all the way back to the Egyptians and you tell them about CRISPR. What we currently know now, people will think is so arbitrary in the future, but we haven't imagined it yet. I truly think neurodivergent individuals are going to be the type of individuals to progress our knowledge. We make amazing scientists. If we can be the leaders of our own destiny by doing research on neurodiversity, then we can make sure that it is ethically done correctly. What did we cover today? We took a bit of a wide view on neurodevelopmental conditions and the history of neuroscience. We learned that neuroscience essentially is the cells and cognition side of neurodevelopmental. We learned at brain practices, such as how we viewed mental health back in the day and how it kind of was massively wrong, but still useful to getting us where we are today. We learned about the Egyptians and how they had their rituals didn't align up to what we consider more important today. We learned about medicine. We learned about different theories and mechanisms and views and how we dissected the brains, different pioneers in evolution. Again, today, I hopefully inspire you to go and learn more. This is just the tip. If you do want to learn more, here is where we got a lot of the information from today. You can see it has all been referenced. All the information can be found in some of these books. If you want to take a more of a lighter dip into learning more about your brain, I would recommend The Reason I Jump and Neurotribes by Steve Silverman. Sadly, Steve passed away really recently this year, but these are more light touches, which can give you a broad understanding of how humans have understood our brains from a scientific perspective, but also from a psychological perspective and by observing individuals. If any of you are neurodivergent and don't have the money and the resources to get fancy fMRI machines or do experiments on yourself, then you can still get support through government grants, particularly in the UK. You can get workplace needs assessments. Here's our YouTube channel where you can like and subscribe. I will be posting my TED Talk as soon as it's available, so please do like, share on that. If you want to contact us, here are our details. exceptionalindividuals.com if you're interested in workplace needs assessments or support in the workplace. Or if you just have a question, admin@exceptionalindividuals.com. Or if you want to email me directly, it's nat@exceptionalindividuals.com. I hope you found it interesting and was able to get the brain thinking. All right, appreciate everyone. Have a good rest of your day.